Hi there, welcome to this video, walking you through some topic 3 questions. This will cover both standard and high level content. So number 1, which trends are correct across period 3? Right, so for the trends, I had this little table that I would make every time I came across these questions. Just a nice jogging of my memory without having to go into the explanations of why something decreases or increases. So this is across the period, atomic radius and ionic radius. They both decrease. Everything else increases. And it is the opposite when you go down. So knowing this, atomic radius does decrease across period 3. First ionization energy also increases. Yeah. Melting point. Melting point has a bit of a stranger trend. It looks like this, roughly. So you can't exactly say that there's an overall increase. So that's going to be B. Number 2, which oxide dissolves in water to give a solution with a pH below 7? So this is a little table that might help you. These are all the period 3 oxides. And this shows you their bonding type, their conductivity, and their pH when they react with water. And by the way, you do need to know all the equations, so when these react with water. So let's take P4O10. What would this give you? Any ideas? Phosphoric acid. H3PO4. You need to balance this. So that will be 6, 4, 1. State symbols. Solid, liquid, aqueous. There we go. Know that for all of the period 3 oxides. But coming back to the question, which one dissolves in water to give a solution with a pH below 7? We're looking for something acidic. So it will be something from this end, acidic. And out of our options, what works is the P4O10. 2D. Number 3, highest pH. Again, check the table. This will be sodium oxide. Number 4, which metal has the strongest metallic bond? So strength is dependent upon charge and upon size. What we want is lots of delocalized electrons, which will make the nuclear pull stronger. So in effect, it will make the size of our ion or of our atom in this case smaller. So charge doesn't really come into it here, it's more size. And in this case, lithium is the smallest. Number 5, which property increases down group 1, the alkali metals? Again, have a look at my table. It will be A. Which element is a lanthanide? So that's this part of the periodic table, and it will be Tb. Number 7. We need to select the correct statement. Okay. The first complex absorbs orange light. If it itself is orange, it means it absorbs the complementary color. The color observed is complementary to the color absorbed. So in fact, this would absorb blue light. B. The oxidation state of cobalt is different in each complex. Let's check that quickly. This is -6 because each one of them is -1. We want to get to -3, so this will be +3. This is neutral, it's 0, no impact. So we want to get to +3, we're at 0, this will be +3. So they are not different, they're both +3. The different colors are due to the different charges on the complex. The different colors could be different due to the charge on the metal ion rather than the complex. So on metal ion. So that leaves us with D. The different ligands cause different splitting in the D orbitals. Yes, that's what ligands are all about. The stronger the ligand, the bigger the split. We're not told which one is strong or weak here. We just know that they're different. Yeah, chlorine is different to ammonia. Those are our ligands here. So we'll stick with D. Number 8. Which electron configuration is that of a transition metal atom in the ground state? So looking at A, neon 3s2, 3p6, 4s1. Okay. The fact that we end on 4s1 should indicate that won't be a transition metal, because 4s1 is this bit here. Okay. So after neon, we're here, neon. We have 3s2, this bit, 3p6, this bit, 4s1. Okay, so it's actually potassium. The next one is argon and then 3d9. We're at argon, 3d9. We are skipping this 4s, which means it has been lost. Okay, the 4s is lost before the 3d, so that means this will be an ion. It's actually the copper 2 plus ion. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 3d9. So it's lost the 4s2, Cu2 plus ion. Okay, copper 2 plus ion. Just having a look at C, we can see that after we have 3d10, so we know that's transition metals. 4s2 is used up, and then we actually move on to 3p2. So that means we've gone through 4s2, we've gone through 3d10, and then we have 4p2. So that's no longer a transition metal, which leaves us with D, argon 4s1, 3d5. It might seem like this 4s1 is incomplete. It should be 2, right? Otherwise, it indicates it's lost 1 electron, so it's an ion. No, this is one of the exceptions, which is chromium. Chromium, okay. So that leaves us with D. Number 9. Order of decreasing ionic radius. Okay. We have Mg2+, Al3+, S2-, and Cl-. This has 12 electrons, 13 electrons, 16, and 17. So decreasing ionic radius. So if magnesium usually has 12 electrons, but it's lost 2, it has 10. So it'll have 2 in its first shell and then 8 in its second. It'll be the same for aluminium. For sulfur and chlorine, they're gaining 2 and 1 respectively. So that will be 2, 8, 8. And again 2, 8, 8. So we know these will be smaller, but how do we rank them between each other? If aluminium has 1 more electron usually in its ground state, it also means it has another proton, 1 more proton than magnesium. Okay, so aluminium has more protons than magnesium, which means there will be a stronger nuclear charge pulling in the electrons, making this ion smaller. Okay, so out of the 2, aluminium will be smaller. We apply the same logic to the sulfur and chlorine, or the ions of those 2. The chloride ion has 17 protons, nuclear pole is stronger, smaller radius, so the chlorine one will be smaller. So decreasing ionic radius, that means our biggest ionic radius will be S, so A or C, S2 minus, and we need to end with the smallest one, which is aluminium, so that will leave us with C. Number 10. What is the charge on the iron 3 complex ion in? Okay, so here's something I want you to understand. Just taken that over to the side so we have more space. What does this CO represent, this cobalt? This is our central ion. What about this chlorine? That's our first ligand. And we have one chlorine. What about this ammonia? That's our second ligand, and we have 5 of them. Okay. From one bracket to the other, that's called a complex ion. From the very beginning to the very end, which includes the chlorine, that's called the coordination compound. And the coordination number for this particular one would be 6, because we have 6 ligands. 1 chlorine, 5 ammonias. Okay, and this question asks us about the charge on the complex ion. So we don't care if there's anything outside of the brackets. Do we have anything outside of the brackets? We do. We have that bromine, and again, we don't worry about that. So water is neutral. OH2, that means -2. We are told it is the ion 3 ion. So that would be 3 plus. -2 plus 3, 1. So that will be B. Number 11. So let's start off by thinking about what first ionization energy is. What's the definition there? The energy required to remove the outermost electron. Okay? That's not the textbook definition. Make sure you know that one as well. But just thinking about the concept, how much energy do we need to remove the outermost electron? So we have neon, sodium, and magnesium. We need to first match them to their respective letters. So the highest ionization energy means the highest energy required to remove the outermost electron. That would be neon. Why? Because neon is stable. Neon is happy. It's got a full outer shell. So it's going to require a lot of energy to remove one electron because it's making neon unhappy. So we know that X is neon. Then we have sodium and magnesium. Magnesium has 2 electrons, sodium has 1. That means magnesium is a bit more stable than sodium. So magnesium will require the second highest energy to remove one of its electrons. So that will make Z magnesium, which leaves Y as sodium. Now they don't ask what is the increasing order of first ionization energy. No. They ask of increasing atomic number. So that will be A. It's neon, sodium, magnesium. Number 12. Ammonia is a stronger ligand than water. Okay. Let's have a look. So the d orbitals in the copper ion split. They do, yeah. They do with ammonia and they do with water. So whilst it's true, let's see if there's something that fits better to the question. There is a smaller splitting of the d orbital. There will be a larger splitting of the d orbitals, okay, because ammonia is a stronger ligand. The stronger the ligand, the bigger the split. So not B. C, ammonia replaces water as a ligand. It does. It's stronger, so it will replace it. The color of the solution fades. I will insert something here to explain that, but that is not the case. So that will be C. Okay. 13, which element is a metalloid? So these are all the elements that lie on that staircase that you might have been told about on the periodic table. So these metalloids have properties of both metals and non-metals. Let's find it on this periodic table. So here is the staircase. And in our options, we have a S. So that will be B. 14, equation that represents the first electron affinity. So this is the opposite of ionization energy. The way that we would write this as a sort of rule, if you like, is like this. So the one that fits the bill here is A. These all need to be in gaseous state, so if any of them were in any other state, then that would also immediately tell you that can't be the right answer, so you can eliminate via that way. Chlorine is gaining an electron. Okay. 15, which solution forms? Well, we actually went through this earlier. Do you remember? So it will be H3PO4, phosphoric acid, and it will be acidic. Phosphoric acid, acidic. 16, which periodic trend is described correctly? If you missed question 1, go back to question 1. I show you a quick way of remembering all of these trends? The answer is D. 17. Which best explains why transition metal complexes are colored? Okay. So we've got two options: as electrons return to lower energy levels and as electrons are promoted to higher energy levels. Do not confuse this with the hydrogen emission spectrum. Okay, so there we get a reading, we get a line when electrons come back, return, go down to lower energy levels. However, that is not the case here. So it will be either C or D. Here we are promoting them to higher energy levels. Light of a certain color is absorbed, yeah, and the complementary color is observed, or the complex appears to have the same color. That would be C. And we touched on this in an earlier question. The complementary color is observed. 18. What is the correct explanation for the color of the substance? A. Light is absorbed when an electron moves to a d orbital of higher energy. Yeah, that sounds good. That follows the rules of that we just saw in question 17. Light is not released. C. Light is absorbed when electrons move from the ligands to the central. No. And D. Light is absorbed when electrons move between d and s orbitals. No, they only move between d orbitals. So that will be 18A. 19. Which property increases down group 17, the halogens? The table that I showed you in question 1 doesn't actually work here. It's not A, it's not C, and my table does not include reactivity and boiling point, so feel free to add those. Make the table better. Reactivity decreases. It decreases down group 17 and increases down group 1. So they're the opposite of each other. So if you know one, you'll know the other. Boiling point. This is our answer. Why? Because as we move down the group, the size of our atoms, the size of our halogens increases. There are more van der Waals forces. Yeah, we go back to forces, topic 4. So that increases the boiling point. Number 20. Which correctly describes the reaction between potassium and excess water? So you've just got to know that this produces potassium hydroxide and hydrogen. So that looks like this. So that's the balanced equation without the state symbols. So that will be C. 21. The oxidation state of cobalt in the complex ion is +3. Which of the following statements are correct? Well, the first one that we could get is this. So the complex ion is an octahedral. It is. We have 1 and then 5, that's 6. And even though for me octa sounded like 8, it might for you as well. Octa is 6 in this case. So we know that's correct. The overall charge of the complex ion is +2. We're told cobalt is +3. Ammonia doesn't have a charge. What would have a charge is NH4, which is +1, but we don't have that. We have NH3, that's neutral. And then we have this bromine, which is -1. 3 minus 1 is 2. So the overall charge is indeed 2. The cobalt-3 ion has a half-filled D subshell. So cobalt is the 7th one along the transition metals. So if you remember, the transition metals are 3D10. So it's the seventh along 1, 2, 3, 4, 5, 6, 7. If we remove 3, we have 1, 2, 3. That is not a half-shelled d subshell because it now has 4 electrons. A d subshell can hold 10, so we would need 5 for that to be correct, which means that will be A. 22, the definition of first ionization energy. Well, we had to define this earlier, didn't we? So we said the energy required to remove electrons, and here's the textbook one, 1 mole of electrons from 1 mole of gaseous atoms. So that will be B. Which statement is correct for the halogens? Again, you can use the table that I showed you in question 1. That will point you towards A. Electronegativity decreases from fluorine to iodine. 24. Here you can have a look at the table that I showed you in question 2 or 3. That will show you that the trend along the period 3 oxides is basic through amphoteric to acidic. Sodium is at the beginning, so that will be basic. And it will be ionic. We have metal and a non-metal. Last one of this video. Well done for making it. What's true about this complex? Ammonia is a ligand. It is. Oxidation state of copper is +2. Well, we know ammonia is neutral. Chlorine will be -2. Looks like our complex is neutral as well overall, which means copper must be +2 to get us to 0. So that is also true. Chloride ions act as Lewis acids. So the chloride ions here, as well as our ammonia, they're both ligands. Lewis acids are electron acceptors, but ligands donate. What do ligands do? They donate. They're molecules with at least one lone pair that form coordinate bonds to the metal ion. So that's incorrect. 1 and 2 will give us A. Nice one. Tune in for more.